Hello guys, my name is Rodrigo and in the following weeks I'll be posting a bunch of videos about graphs, dynamic programming, greedy algorithms. So if you're a big nerd like myself and you want to learn a ton, please subscribe to the channel and also follow the Facebook group where I organize weekly algorithms meetups. So today we're gonna actually solve a very interesting problem called clone indirected graph. What is cool about this problem is that you can cheat. So what do I mean by cheating? Let's suppose I have this graph here, A, B, C, D, and you wanna clone a graph that is similar to this one. What we can't do is create a so before I start, I actually have to explain to you how the graph will be given. So the graph will be given as a reference to one node. So let's assume we're given just A, and from A we can get through the neighbors all the graph basically. What we can't do is, okay, the head, let's call it the head of the node is A. I'll create another node A, and basically I'll create new references that copy the neighbors of A. So this new A, let's call it A prime to B, A prime to C. There we go, we return A. So we just change the references and we have the clone of the original graph. That can't happen. For every node of the graph, we need a new copy. The way a graph is represented in this example is through a class indirected graph, which has two fields. It has the label, which basically can be a number. In our scenario, I'll use a letter, and an array of neighbors where we'll put everyone connected to the particular node. So for A, we'll have B and C. For B, we'll have A, C, D, and so forth. How are we going to approach this problem? To keep track of all, so basically we start with A. We're going to create a copy of node A. So we are going to create A prime, like I said previously. But instead of pointing the node to old nodes, like I did previously to B and C, we are going to store that copied node as a value of A in a hash map. So we'll create it will be value A, and this A is actually an object. So the label of the object will be A prime, and then we'll have an empty array with the neighbors. In this way, as we're traversing the original graph, we can create objects and mappings that will create a copy of the graph. So in this example, a copy of the original graph would be A prime, which is a new node, will be connected to B prime, which will be a copy of B, and C prime. B prime will be connected to A prime, C prime, D prime. See, and when I say A, I say object A. So this actually also has a label and neighbors, but I'll not show it here because I assume you guys know how an object works. So C will be connected to C prime, which is connected to A prime, B prime, D prime, and finally D is connected to, so this is an object. This is I'll actually have a pointer which will have a label and neighbors. Finally, D prime is connected to B prime and C prime. And then finally what I'll return is a pointer to A prime, which is the copy of the original. The way we represent the neighbors is through this array. So basically, knowing the label is A prime and that the nodes are B prime and C prime, I just return a pointer to this object and then I can explore every other node from there. So with the help of a hash map, we'll be able to copy the original graph. So how does this look in code? We can have three approaches: breadth first search, iterative, DFS iterative, and DFS recursively. So how does it look like? So if not node, meaning we are given an empty graph, we return. First thing we do is we create a node, in this case a prime. It will have empty node, it will have no neighbors at the beginning. We put it in the hash map like here, and we put it in the queue, which is a standard procedure when we do breadth first search. Then we do the actual breadth first search. So we're gonna pop A, we'll pop A and visit all the neighbors of A, in this case B and C. If B and C are not visited, we're gonna create the copies. So we're going to create B prime and C prime, and that's what we do here. So let's say the first neighbor we visit is B. We're going to create here a B prime. Then we're going to put B prime in the hash map. And now we're going to put B prime as a neighbor of A prime. So we're gonna say, so dictionary node, what is node? A, it's the first node. Neighbors, so we're accessing B prime, A prime, and we are accessing out the neighbors. And now we want to put B prime as a neighbor of A prime. That's what this line here does. So here we're gonna add B prime. And finally we add B to the queue because we want to explore all the neighbors of B. So in this way, after we explore all the nodes using BFS, we'll have a copy of the original graph, and what we do is just return node.copy, which is the pointer to A prime. That's it. We can use the same process, but instead of a queue, we use the stack. The running time will be the same. And another way is to call the function recursively, but the way it will work will be very similar to this one, DFS iterative. The running time will be V plus E or M plus N, meaning the number of vertices and the number of edges. Now let's take a look how it works in code. So here we have a graph. I built an undirected graph node very similar to the one we have here, A, B, C, D. It's the same graph. And now I put a breakpoint so you guys can see what happens. So let's run. We run. So now we have node. So we start with A. A has a bunch of neighbors, so it has neighbor B and neighbor C, just like the example here. And node copy will be a copy of A. Observe that the label is the same, but let me extend this. So this is the code of the pointer. Observe that we have different pointers, meaning this is a different object from this one. Although the label is the same, it's a different animal here. It's a different object. So now we're gonna do a breadth first search. We're gonna pop A, not the copy A, the original A, so we can explore its neighbors. Now we grab the neighbor B, so we can create a copy. Have we visited B? No. So what we're gonna do is we're gonna create a object that is a copy of B. So observe we have node copy. let's node copy, which also has label B, but is different from the original B, right? And now we're gonna append this copy of B, which I explained as B prime, to the neighbors of A prime. The neighbors of A prime is a value of A. So we access A prime using this highlighted part. This we access the neighbors of A prime, and this we append the copy of B prime to A prime's neighbor. Finally, we append B to the Q. So if you observe, let's look at the hash map. Now we have two entries on the hash map, A and B. So we have the original A. Let me take a look. Yes, so I still haven't added. So once I step, you'll see A will have B prime as one of its neighbors. B prime. If we click here, you guys can see it is B, which is B prime. It is B prime. So we keep doing that over and over again. And in case it's already in the dictionary, we don't need to create the node. The node already exists. The prime of that node already exists. So let's say I'm here at D, but I already created B prime. What I have to do is just add B prime as a neighbor of D prime, which is a neighbor of D. We don't need to recreate the node. So that's how we copy a graph. If you guys have any questions, please leave in the comments. I'm open to suggestions. Please enter the Facebook group to get more content and also take part in the weekly lives. Hope to see you guys again in the next videos.